Good morning all. Today we are going to discuss module 4. So first two modules deals with statics. So here we are mainly dealing with dynamics. So it is a branch of mechanics dealing with the bodies in motion. It is mainly divided into kinematics and kinetics. So in module 4 we are dealing with linear motion. We are discussing both the kinematics and kinetics of linear motion. So kinetics deals with the motion without considering the cause of motion. The cause of motion is force. So we are not considering force in kinematics. Instead, we are studying the geometry of motion. That is, we are discussing what is displacement, what is velocity, what is the acceleration, etc. So in the same module, we are dealing with the kinetics also. So in kinetics, we are considering the cause of motion. So the cause of motion is force. We will be dealing with force. So there we have to apply Newton's second law. So according to Newton's second law, rate of change of momentum is directly proportional to the applied force. That is, from the Newton's second law, we have already derived F is equal to m into A. So in the first session, we are mainly dealing with the rectilinear motion, that is, motion along a straight line with variable acceleration. That is, acceleration changes at every instant. So before going into that topic, we will discuss what is displacement. So displacement is the change in position along a particular direction. So that definition you have already studied in your class 11. So displacement is a vector quantity and the unit of displacement is meter. And usually we denote the displacement as S. So second term is velocity. It is the rate of change of displacement. Its unit is meter per second and it is denoted as V. Again it is a vector quantity. So we can write the equation for velocity as ds by dt. So next term is acceleration. So acceleration is the rate of change of velocity. Its unit is meter per second squared. It is denoted as A. It is also a vector quantity. So here acceleration A is equal to dV by dt. So here you can write for V. V is actually ds by dt. So we can write here acceleration as dV by dt, or you can write as d square s by dt squared. So next we can change this equation, that is A is equal to dV by dt. So here we are multiplying the numerator and denominator with ds. So you can rearrange these terms, dV by ds into ds by dt. So ds by dt we have already discussed, that is the velocity. So acceleration can also be written as V into dV by ds. So now, while solving the problems using variable acceleration, you have to use these three equations. That is, first equation is velocity. Velocity is ds by dt. So here in the problems related with variable acceleration, the displacement will be given as a function of time. So if the displacement is given as a function of time, by differentiating the displacement you will get velocity. So after getting the velocity function, that is velocity in terms of time, you can differentiate it to get the acceleration. So at that time you have to use this equation, acceleration is equal to dv by dt. So suppose you are given the acceleration as a function of displacement and velocity. So if you are given acceleration as a function of velocity or function of displacement, then you have to use this equation. So in this topic you can expect a 3-mark question. So the first question, a car moves along a straight line whose equation of motion is given by s is equal to 12t plus 3t square minus 2t cube. So here the displacement is given as a function of time. So the first question is you have to calculate velocity and acceleration at start. So at start means t is equal to 0. Second question, acceleration when velocity is 0. So here the question, displacement is given as a function of time. So you can rewrite this equation. That is, in order to get the first value, that is velocity, you have to differentiate this equation. So you are going to differentiate this equation, that is ds by dt is equal to 12t. When you differentiate it, you will get 12 plus 3t square. So 3t square, when you differentiate it, you will get 6t minus 2t cube. 2t cube is 6t square. So you can rewrite the equation as velocity is equal to 12 plus 6t minus 6t cube. That is your equation 1. So to calculate the velocity at start, you have to substitute t is equal to 0 in equation 1. So you will get velocity as 12. So now in order to calculate the acceleration, you have to differentiate equation 1. That is dv by dt, that is equal to 12 is a constant. So when you differentiate it, it will be 0. 6t, when you differentiate, you will get 6. 6t square, on differentiating you will get 12t. So 6 minus 12t. So now this is the equation for acceleration. You can substitute t is equal to 0 to get the answer for the first question. Acceleration is 6 meter per second square. So now you have to calculate acceleration when velocity is 0. So you have to start with the velocity equation. So velocity equation is equated to 0. You will get time as equal to 2 seconds. So you have to substitute this value in equation for acceleration. So you will get a minus 18 meter per second squared. So now the second question, equation of motion of a particle moving in a straight line is given by s is equal to 18t plus 3t square minus 2t cube. Find first one, velocity and acceleration at start. So here you have to calculate velocity. Velocity v is equal to ds by dt. That is, you are going to differentiate this equation. That is equal to 18 plus 3t square. When you differentiate it, you will get a 6t. Then 2t cube will be 6t square. So this is the equation for velocity. So now you can substitute t is equal to 0 in equation 1. Then you will get a velocity as equal to 18 plus 6 into 0 minus 6 into 0 square, that is equal to 18 meter per second squared. So next you have to find acceleration at start. So you have to differentiate equation 1, that is dv by dt is equal to 18. When you differentiate, you will get 0, then 6t, that is equal to 6, minus 6t square, that is equal to 12t. So acceleration is equal to 6 minus 12t. So here also you have to substitute t is equal to 0. T is equal to 0 in equation 2. So acceleration is equal to 6 meter per second squared. So next question, time when particle reaches its maximum velocity. So to get the maximum velocity, you have to differentiate the equation of velocity and equate it to 0. So when you differentiate the equation for velocity, when you differentiate it, you will get this equation, that is equation 2. So in this equation, you have to substitute acceleration is equal to 0. So to get maximum velocity, differentiate the equation of velocity. This is the equation for velocity. So this is the equation for velocity. This is differentiated and equated to 0. So here in the equation 2, you can substitute 6 minus 12t is equal to 0. This is the answer for second question. 6 minus 12t is equal to 0. So from this equation you will get t is equal to 6 by 12, that is equal to 0.5 seconds. So now the third question, maximum velocity of the particle. For that you have to substitute this value. So that is substituted in equation 1. So V is equal to 18 plus 6 into 0.5 minus 6 into 0.5 square. So that is equal to 20.5 meter per second. So this is the answer for the third question. So now the third question, motion of a particle is given by A is equal to t cube minus 3t square plus 5. The velocity of the particle at t is equal to 1 second is 6.25 meter per second and the displacement is 8.8 meter. Calculate the displacement and velocity at t is equal to 2 seconds. So here the acceleration is given as a function of time. So in order to calculate the displacement and velocity, you have to integrate. So we are starting with the equation for acceleration. Acceleration is equal to t cube minus 3t square plus 5. So here instead of acceleration A, you can write dv by dt is equal to t cube minus 3t square plus 5. So now dv is equal to t cube minus 3t square plus 5 into dt. So on integrating you will get left side you will get velocity. Here it is t cube. When you integrate you will get t raised to 4 by 4 minus 3 t square. That will become 3t cube by 3 plus 5t. Then you have to add the constant of integration that you can take as C1. So now the next step is you have to calculate the constant of integration. For that, the boundary conditions will be given in the question. The velocity of the particle at t is equal to 1 second is 6.25. So here you have to substitute the boundary condition at t is equal to 1 second. Velocity is 6.25. So you can substitute in this equation. You can write this as equation 1. So 6.25 is equal to 1 by 4 minus 3 by 3 into 1 plus 5 into 1 plus C1. So solving this equation, you will get a C1 as equal to 2. So now the equation for velocity, V is equal to t raised to 4 by 4 plus minus 3t cube by 3 plus 5t plus C1. C1 is 2. So this is the equation for velocity. So now you have to calculate the displacement and velocity at t is equal to 2 seconds. So this is the equation for velocity. So in this equation, substitute t is equal to 2. T is equal to 2 seconds. So velocity is equal to 2 raised to 4 by 4 minus 3 into 2 cube by 3 plus 5 into 2 plus C1. C1 is 2. So here the velocity is 8 meter per second. So next you have to calculate the displacement when t is equal to 2 seconds. So here you have to start with the equation for velocity. So velocity equation is t raised to 4 by 4 minus t cube plus 5t plus 2. This is your equation 2. You can assume this as equation 2. So this you can substitute as equation 2. So in order to calculate the displacement, you have to start with this equation. So here you have to substitute ds by dt. This is equal to t raised to 4 by 4 minus t cube plus 5t plus 2. So ds is equal to t raised to 4 by 4 minus t cube plus 5t plus 2 into dt. So the above equation you have to integrate. So here s is equal to t raised to 5 by 5. So 4 into 5 is 20 minus t cube. When you integrate, you will get t raised to 4 by 4 plus 5t, that is t square by 2 plus 2t. Then the constant of integration you have to assume as C2. So now in order to calculate the constant of integration C2, you have to refer to the question. So in this question, when t is equal to 1 second, velocity is 6.25 that you have used to calculate a C1. So now the displacement is 8.8. So that data is used to calculate C2. So when t is equal to 1 second, displacement s is equal to 8.8 meter. So here 8.8 is equal to 1 by 20 minus 1 by 4 plus 5 by 2 plus 2 plus C2. So So on solving this equation, you will get a C2 as equal to 4.5. So now you can substitute the value in this equation, that is equation 3. So here S is equal to t raised to 5 by 20 minus t raised to 4 by 4 plus 5t square by 2 plus 2t plus C2. C2 is equal to 4.5. So this is the equation for displacement. So here you have to calculate the displacement when time is equal to 2 seconds. So in this equation you have to substitute t is equal to 2. So substituting in equation 4, t is equal to 2 raised to 5 by 20 minus 2 raised to 4 by 4 plus 5 into 2 square by 2 plus 2 into 2 plus 4.5. So on solving you will get displacement as equal to 15.6 meter. So next we will see the rectilinear motion with the uniform acceleration. So here the acceleration will have a constant value. So these are all review topics which you have studied in your class 11. So you have already studied the equations of motion. So these are the three equations of motion. First equation of motion is V is equal to U plus AT. S is equal to ut plus half at squared and v square is equal to u square plus 2as. So here in this equation u represent the initial velocity, v represent the final velocity, s is the displacement, a is the acceleration and t is the time of travel. So using this three equations of motion, you can solve the problems in rectilinear motion. So here the uniform acceleration means the value of the acceleration is a constant. So now the first question, a bullet is moving at a rate 250 meter per second. So here the unit is 250 meter per second. Meter per second is the unit of velocity. So it is fired into a log of wood. The bullet penetrates to a depth of 40 centimeter. So here this is a linear measurement. If the bullet moving with same velocity is fired into similar piece of wood 20 centimeter thick, with what velocity would it emerge? Take the resistance to be uniform in both the case. So here you are having two different cases. A bullet is moving with a velocity, that is initial velocity is 250. So it is fired into a log of wood. In the first case, the depth of the wood is 40 centimeter. So in the second case, the thickness of the wood is 20 centimeter. So you have to calculate the velocity with which the bullet comes out from the second wood, that is 20 centimeter thick wood. So here you have to consider two different cases. In the first case, you are considering a 40 centimeter thick wood. So here the distance is 40 centimeter. 40 centimeter, that is equal to 0.40 meter. So in the second case, this is case 1, and in case 2, the thickness of the wood is 20 centimeter, that is equal to 0.2 meter. So here the initial velocity is 250 meter per second. In the second case also, initial velocity is 250 meter per second. So in the first case, final velocity is 0. Second case, you have to calculate the final velocity. So here you are having three equations of motion. First is v is equal to u plus at, s is equal to ut plus a half at squared. Third one, v square is equal to u square plus 2as. So from the given data, you have to select the suitable equation. So here the displacement is given, initial velocity is given, final velocity is given. So you have to choose the third equation of motion, because you have final velocity, initial velocity and displacement. So only unknown is acceleration. So we are going to use that. V square is equal to u square plus 2as. So that is 0 is equal to 250 square plus 2 into a. A is unknown, s is equal to 0.4. So from this you will get acceleration, which is a minus value 78125 meter per second squared, because it is a deceleration. That is why you are getting a negative value. So now you have to go to the second case. So in the second case, so for the second case, figure is given here. Displacement, distance travelled is 20 centimeter. Initial velocity is 250. You have to calculate the final velocity. The acceleration, you are getting this value. So here initial velocity is 250 meter per second. Acceleration is minus 78125 meter per second squared. And the displacement is 0.2 meter. Again you are going to use this equation. So here final velocity you have to calculate. Initial velocity is 250, acceleration is this value, displacement is given. So here v square is equal to u square plus 2as is equal to 250 square plus 2 into minus 78125 into displacement is 0.2. So from this equation you will get a v is equal to 176.77 meter per second. So now the second question, a burglar's car had a start with an acceleration of 2 meter per second squared. A police vigilant party came after 10 seconds and continued to chase the burglar's car with uniform velocity 40 meter per second. Find the time taken in which the police van overtake the car. So here you have to calculate the time taken at which the police van could overtake the car. So here we are assuming the initial velocity of the burglar's car. Initial velocity of the burglar's car is taken as 0, because the burglar's car had a start with an acceleration 2 meter per second. So initial velocity is assumed as 0, acceleration is 2 meter per second squared. So this is why we are taking initial velocity as 0. The car had a start. So that is why initial velocity is 0, acceleration is 2 meter per second. So now a police vigilant party came after 10 seconds and continue to chase the burglar's car with an uniform velocity 40 meter per second. So here the police vigilant party came after 10 seconds. So the burglar's car will be in motion for 10 plus t seconds, where t is the time taken by the police van to overtake the burglar's car. So you can assume t as the time taken by the police van to overtake burglar's car. So the burglar's car will be in motion. Car will be in motion for t plus 10 seconds. So now we will consider the equations of motion. We have three equations of motion. V is equal to u plus at, S is equal to ut plus a half a t square, p square is equal to u square plus 2as. So here, based on the data, so you have to select the equation. So here initial velocity is 0, acceleration is 2, and then time. So you can have to use the first equation. So we are choosing the second equation because you have to find the time taken for which the police van should overtake the car. So we are going to use the second equation. So for the second equation you have S is equal to ut plus half a t squared. So here u is equal to 0. Then you have half into a is equal to 2 and t. So here the burglar's car will be in motion for t plus 10 seconds. So here you have to substitute t plus 10 whole square. So here you have to write t plus 10 whole square is equal to t square plus 20t plus 100. So now this is the first equation. So now in the question, the police vigilant party came after 10 seconds and continued to chase the burglar's car with uniform velocity. So here the police vigilant party came after 10 seconds and continued to chase the car with uniform velocity. You have to calculate the time at which the police van overtake the car. So when the police van overtake the car, displacement should be equal to or more than. So here we are assuming the displacement of the police van or the distance travelled by the police van. So the distance travelled by the police van. So here the distance travelled by the police van is given by the equation S is equal to. So here the police van is moving with uniform velocity. So uniform velocity means acceleration is 0. So here you are using the same equation ut plus half a t squared. So here acceleration is 0. So displacement is equal to 40t plus 0. So this is your second equation. So now you can equate equation 1 and 2. So equating equation 1 and 2, you will get a 40t is equal to t square plus 20t plus 100. So from this equation you will get t is equal to 10 seconds. So here in this question, the first assumption we are doing is u is equal to 0. So here the initial velocity is not provided in the question, and they are saying that the burglar's car had a start with an acceleration 2 meter per second. That is why we are assuming initial velocity as 0. Second, we have to calculate the time at which the police van overtake the car. So when the police van overtake the car, displacement should be equal to or more. So here we are assuming the displacement as equal. That is why we are equating equation 1 and 2. So here the police van came after 10 seconds. So here the second assumption we are doing is time taken by the police van to overtake the burglar's car is assumed as t. So therefore the burglar's car will be moving for a time t plus 10 seconds. So this is a very important question. So now the next question, on turning a corner, a motorist rushing at 20 meter per second find a child on the road 50 meter ahead. He instantly stops the engine and applies brake so as to stop the car within 10 meter of the child. Calculate the retardation. That is, when brake is applied, you will get the retardation. Second time required to stop the car. So here on turning a corner, motorist rushes at 20 meter per second. So here the initial velocity is 20 meter per second. Find a child on the road 50 meter ahead. So he instantly stops the engine and applies brake so as to stop the car within 10 meter of the child. So here he sees the child at this position, which is 50 meter ahead. But he have to stop the bike at a distance 40 meters. So here we have to assume the displacement as 40 meter because he had to stop 10 meter before. So the displacement is assumed as 40 meter. So when the brake is applied, he will stop the vehicle at this point. So velocity is equal to, that is final velocity is equal to 0. So you have the three equations of motion. V is equal to u plus at. This is equal to ut plus a half at squared. Then v square is equal to u square plus 2as. So now you have to refer to the data. Initial velocity is given, displacement is given, final velocity is given, and you have to calculate retardation. So you have to choose this equation, that is v square is equal to u square plus 2as. So v square is equal to u square plus 2as, that is equal to 20 square plus 2 into a into s. S is equal to 40. So acceleration, that is actually retardation, that is 5 meter per second squared. So second, you have to calculate the time required to stop the car. So in order to calculate the time, you are having final velocity, initial velocity, then acceleration. So you can use this equation, or else if you want to use the second equation, that is also possible. So now the time required, that is Using this first equation, b is equal to u plus at. B is equal to 0, u is equal to 20, then acceleration, this is actually retardation, that is why you are getting negative sign, so minus 5 into t. So on solving, you will get t is equal to 5 seconds. So now the next question, a motor car takes 10 seconds to cover 30 meter and 12 seconds to cover 42 meter. Find the uniform acceleration of the car and its velocity at the end of 15 seconds. So here you are given two different situations. A motor car takes 10 seconds to cover 30 meter. That is the first case. Second case, it takes 12 seconds to cover 42 meter. You have to calculate the acceleration and the velocity at the end of 15 seconds. So here you have case 1 and case 2. So in case 1, t is equal to 10 seconds and displacement is equal to 30 meter, and in case 2, t is equal to 12 seconds and displacement is equal to 42 meter. So you have the three equations of motion. V is equal to u plus at. Second equation, s is equal to ut plus half at squared. Third equation, v square is equal to u square plus 2as. So here in the question, you have to calculate uniform acceleration and then velocity. So first you have to calculate the uniform acceleration. So here displacement is given, time is given. So you can use the second equation of motion to calculate the acceleration. So in the first case, 30 is equal to, that is s is equal to 30, u is not given, u into 10 plus half into a is also not given, so 10 square, that is equal to 100. This is your first equation, and similarly you have to apply the same equation in case 2. So in case 2, s is equal to 42, then u is initial velocity into 12 plus a half into a into 12 square. 12 square is 144. So here you have 30 is equal to 10u plus 50a. So here you can write this as your equation 1. So here you can write 42 is equal to 12u plus 72a. That is your equation number 2. So now you are going to multiply equation 1 by 6. That is 180 is equal to 60u plus 300a. That is your equation number 3. And you are going to multiply equation 2 by 5. That is 210 is equal to 60u plus 360a. That is equation 4. solving 3 and 4. That is 180 is equal to 60u plus 300a. Then 210 is equal to 60u plus 360a. We have to put a negative sign here. This get cancelled. Sixty is equal to here this is 30. 30 is equal to minus 30 is equal to minus 60a. So a is equal to minus 30 by minus 60. That is equal to 0.5 meter per second squared. So now you can calculate the velocity. Velocity at the end of 15 seconds. You have to calculate velocity at the end of 15 seconds. So you can use this equation. Velocity at t is equal to 15 seconds. Initial velocity you have to calculate. So here the initial velocity is, from this equation you will get initial velocity as 0.5 meter per second. So final velocity when t is equal to 15 seconds is equal to 0.5 plus acceleration is 0.5 into time, that is equal to 15, is equal to 8 meter per second.